Welcome back to Interact Learn by Doing Season 2 Project 3. Thank you all for waiting. It's been a long time coming. Now, of course, for this course, we'll be recreating 2 of my body tracking R&Ds made in Unreal Engine 5, as you see right now. And like usual, please watch the latest project setup video to follow this course. Now, if you're ready, you should have a template ready to go, just like this. Okay, so if you're used to any of my Learn by Doing series, what we're going to do is we're going to duplicate this template. So Control-C-V, and let's rename this to LBD S2P3. And since I already have this named project file, I'm just going to add a D for demo, and I'm just going to Control-A this and copy, and inside we're going to rename this here as well. And then what we're going to do is we're going to delete everything except for config. So that's in the intermediate. The next one is saved. Delete that. And then we should be able to delete this. And I think we're ready. So we're going to regenerate some of these files. So let's enter. Okay, so before we get any further with the Unreal Engine 5 editor, we need to talk about the sensor. Now I'm going to be using the Kinect Azure. If you are also, then please install the SDK, and you should be able to access this thing here and click on your K4 viewer, and you should have your device and be able to preview it just like this. I'm just in a very tiny Airbnb at the moment, so let's just stop that. And if you're on Kinect 1, you need your Windows runtime as well as the SDK, and have this here, which is the SDK browser, and run this and make sure that everything is green. I can't do that right now because I don't have the Kinect 1. Okay, there it is. Anyways, if you're done with that, we can move on to TouchDesigner. All right, so I have TouchDesigner open right now. I have a commercial license, but to follow this course, you don't need it. You can use the non-commercial one. And I have a blank project. And of course, with the workflow, okay, let's start with Kinect 1. So for Kinect 1, you just have one chop, which is here. And you should be able to select your sensor here. And then for you, you need to be focusing on getting your hip ID and then the left hand and the right hand. Okay, and if you're in Kinect Azure, like me, you need 2 nodes. First, the Kinect Azure chop, as well as the Kinect top, which is here. And then you need to drag this into the top. Okay, I think I'm connected here, so I'm going to close that. Okay, great. And then I'm going to just copy the parameter here and paste it in the chop, so it's going to be there. And then for us, we are looking at pelvis ID and left hand, right hand. So I'm just going to get the select node over here and then grab, actually I'm going to take 2, so just Control-C and V this. So for this bottom one, I'm just going to be taking the ID, and then for this one, I'm just going to do it the lazy way and select it one by one. And I'll see you when I'm done with this. Okay, so once you are also done with that, you should have the same here. Left XYZ, right XYZ, pelvis XYZ, and ID down here. Okay, so for these, I'm going to use a lag chop to smooth the values out. I'm just going to bump it up here to 0.4, and then we need a merge. So let's get a merge, put these 2 together, and then we do an OSC out, which is our good friend, as you should all know. So connect that. Localhost is fine. I'm just going to change it to 3000. And then now it's basically to save, so please go and do that. Okay, so once you're saved, we can move on to Unreal Engine 5. Okay, so now we're back into Unreal Engine. And of course, to have OSC working in Unreal Engine, we need to enable the plugin. So let's go into our edit plugins, search for OSC and enable that. And you need to restart the project. Okay, now that your Unreal Editor has restarted, I'm going to bring up a strange issue that I found upon testing the version 5.5.0, and it's that with the OSC plugin, for some reason, localhost doesn't work. And this has already been flagged in the Unreal Engine forums. And so for this, we're going to be using a workaround, which will also be very useful for you if you're trying to set up OSC with multiple machines. Okay, so here's a workaround. So I use this method if I have more than one machine communicating via OSC. So what I have is basically the powerful machine on this side, which is running Unreal Engine, and then this side, which is the more, lower spec laptop that's running TouchDesigner and just gathering sensor information. And so here is the onboard Ethernet port, which sends out OSC and gets received to the USB adapter, which is turned into a receive point. So the workaround in this case, because of this weird issue with the OSC plugin, we're just going to feed it back into our laptop. And that's what basically will allow us to make a fake localhost. And I would say this is the second best option after localhost, because the Wi-Fi method, it's very unreliable, and also it has a lot more latency. So that's a trick that we're going to be implementing if currently you're watching this course and the issue has not been resolved. Okay, why don't we get back into Unreal Engine? So knowing what we know about this bug, we're going to be creating first the blueprint which receives OSC into Unreal Engine. So first of all we need to do, right click to create a new class, actor. Let's call this one BP OSC receiver 1. Let's enter. Okay, and in the event graph is where we'll be placing our code. I'll get rid of 2 of these. Now, if you've taken any of my courses, you should be familiar with this workflow, but with this body tracking setup, it's going to be a little bit difficult. So even if you know the workflow, please continue to watch. So of course, like usual, we will create an OSC server. Let's connect that here. Port number is 3000. And start listening from the beginning. And let's take the IP address of our USB Ethernet adapter and paste it here. If you don't have this issue when you're watching this, you can put 127.0.1, but our case, it doesn't work, so we're going to put that. And then we need to save this as a variable, so promote, call it OSC server. Okay, and then when we get that, we need to bind an event on OSC message received. Let's put that in, and we'll create a new event that'll be tied to this event. So let's do custom event. Okay, not this one. Create event. Okay, and then all we need to do is to create a matching event. Let's call this one OSC_in. Move this down. We need to save the message because we need to access this later. So promote the variable OSC_MSG. Okay, the first thing we need to do is we need to convert or get OSC message address. Okay. And then this needs to be converted to string. Okay, and I'm also going to save this address. So promote OSC_address. There you go. And then what we'll do first is we will print string because we need to preview the format of our address. Let's go ahead and compile and save. And then let's just drop this in, zero it out. And then let's open TouchDesigner next to test it out. Okay, so here we are in TouchDesigner. If you remember, we had it configured with localhost for OSC out node, but I've already changed it to the IP address of the USB Ethernet dongle. Okay, so if we run this and go back into Unreal Engine, we should be able to receive and see what we're getting with the OSC addresses. So let's take a note of this. We first don't need the very head of the string, which is the slash. And then later we'll use a split string to get the right-hand side of the string. So the hand R, ID, all those things. And we'll do another split to get the TX, TY, and TZ. So we'll be doing that right now. So let's just stop our TouchDesigner for a second here and go back into the OSC receiver. We can get rid of this. And so what we'll do is we'll put a sequence. And if you remember, we have 4 things. So pelvis, hand, left, right, and ID. And so we'll first need to make a function that will extract exactly what we need. Actually, before we make that function, we need to process the OSC adder string, as I've explained before. So we're going to do that before we set this variable. So the first thing we need to do, of course, is to remove that slash in the front of the string so we can use a right chop. And so it says you can return the string right and then cuts from the beginning of the word, which is what we want. And we only cut the first character, so only 1 for the count. And after that, we do a split string. There you go. Let's move this over and plug the right-hand side. And the search condition is going to be the slash. So of course, when we do this, on the left-hand side, we'll get P1. And the right-hand side is all the names that we want, like hand L, hand R, things like that. Okay, so this is ready. And then we make the function right now. So let's go and create a new function. Let's say get value XYZ, because it will get the value for each of the axes. So we need to make 2 inputs, which are going to be string. So the first one is going to be the type. And then the second one also is a string. It's going to be the axis. Okay, so we're going to first check in the OSC address. We're also going to split again. And this time it's going to be the double dots, which somehow I don't know the name of. So we'll first check if the type is equal. Case insensitive should be fine. And if that's correct, after a branch, we need to check if it's the same axis. So we'll take this and we'll take that. And then we'll just do this because I'm lazy. And if it's true, we can get our message. And then we can get our float at index. There you go. And then we can output this at the end. So click on that. Let's move this over. And then we can just drop that in here and get rid of this. Okay, and we can compile this, go back in here and drag the function in. Okay, so how we're going to use it is basically to duplicate 2 more times for our each axis. So complete that. Let's connect this up. And then for type, first one is going to be pelvis. So type in pelvis. We're just going to copy that and paste it. And then the axis is going to be TX, TY, and TZ. Now we can do the same thing down here and do hand underscore L. Let's just copy that and paste. Do the same thing here. And then we need to get this here. Hand R for right. We'll get back to ID later. What we need to do now is to make a vector from this. So make vector. Now for X, it's going to be here. And now for Y, the thing is in TouchDesigner or the Kinect sensor, Y is going to be the Z in the Unreal Engine axis. So we're going to plug that into Z. And then our Z in the Kinect is going to be the Y. So we already have spaghetti here, so we're gonna try to make it neat using some reroute nodes. Just like that, and that should be it. And then we set this to a variable, so let's create a new variable and call this one pelvis. And let's set it here. There you go. Let's do a bit more cleanup. And so to have the same wiring, we're going to connect or select these. Let's duplicate it and bring this down. Should be okay. So that's going to be here, here, and here. Let's move this in so it's matched. We need to create a new variable, so we're going to duplicate that, and this is going to be for hand underscore L. What you can do is you can drop this on top and change the node, plug that in. Let's do the same thing. Duplicate. Looks like we need to push this back a couple spots, and then let's bring this over like the others. Y, and then the X. There you go. Let's move this in. And this one as well. Again, let's duplicate this for right hand. Drop that on top. And then connect it. So this basically should be it. Okay, and now for the ID, we're just going to do it manually. So OSC address, if it is equals to ID, and get a branch. And we're going to take this here. There you go. Let's make a bit more space here. And then we just do message get float. Let's do that. And then instead of saving the float, all we need to do is if it's greater than 0, it means our installation is active. And if it's not, it is inactive. So we'll make a new variable. So let's do it sensor active question mark. And if it's greater than 0, it is active. If it's not, it is false. Okay, and that should be good. And I'm pretty happy with it, so we can compile and save. All right, now we can receive stuff from TouchDesigner into Unreal Engine through OSC. We need to use these values, and we're first going to make a new blueprint actor that's going to be a previewer for the body tracking. That would also bridge the gap between the body tracking and the effects that we'll create later down the line. So of course, we go into our content browser. Let's create a new actor. Call this one BP body track interface 1. Let's enter this. Now for this one, we will be placing some meshes. So let's add in a sphere. We're gonna call this one hand P hand R. So preview hand R. Let's scale this down to 0.25. And then for the right hand, we'll make it orange. Let's Control CV that. Name this one left hand. Give this one white. And then for the pelvis, we'll use a cube. Put it back into the same root or the origin. Call it pelvis. And then scale it down to like 0.2. Give it a green. Okay, that looks fine. So compile and save. Let's go into the event graph. Get rid of this. I don't think we need event begin play. We can get rid of that. And then in the event tick is where we'll be doing everything. So we need a reference to the OSC receiver. So we need a variable OSC underscore receiver. We need to expose this to the level. Let's get the type right. So where is it here? OSC receiver 1. Okay, we have that. So what we first do is get a sequence. And then we need to get all the variables. So we have hand L, hand R, pelvis, and the active. I think it's called sensor active. So sensor, okay, where is it? Sensor active, there you go. Okay, and I would say it's better if we just split it. It's gonna be cleaner. Okay, and the workflow is going to be basically the values coming in from touch are gonna be 0 to 1. And we need it basically more like 0 to 100 because that's sort of the scale that we're working at in Unreal Engine. So we will create a new variable, which is going to be of type vector. And that's going to be the tracking scale. And we will expose that as well. Let's compile and give it a scale of 100. So why is 100 is because when we go from like Houdini to Unreal, to get the equivalent scale, it's 100x. That's the way where we do it if we're doing an FBX export or import, sorry. And so we do that. And basically we do this. We need to take the tracking scale and multiply it. And then we'll save this as a new variable. So pelvis underscore S for scaled. Let's put that here. Maybe for us to not get confused, we will do S underscore pelvis. Okay, and then we will make two new variables. S for hand L, S hand R. And we will follow the same process here. Take a bit of time, but it's gonna be okay. We'll do that. I think it's right here, and then we'll take the left hand. Let's bring these over. Take these. I think we can take that as well. And the same trick, you can just drop this on top to change it. Let's plug that in and move it over so it's the same distance. And then the last one, we just save it directly. Sensor active. Let's just call it active. There you go. Yeah, that's all good. I would also say, why don't we make a new seed root? So origin, and then parent it down here. And then let's take a new variable, do a tracking offset. And let's move this on top. So this is if we want to put in a manual offset before we run the game. So before we run the game means it's going to be in the construction script. So let's go to the origin, and we will add a relative offset or add relative location. And the delta is going to be the tracking offset. There you go. Okay, we can compile and save that. So we have these variables. We're going to basically now apply it into each of these preview meshes. So take these. So we have pelvis first. We'll need to set its relative location. So do that. And we take our scaled pelvis value. Let's copy this. Actually, we can just do that. And then let's replace it. Okay, and then we can duplicate that, swap that with the right hand the other way, sorry. Let's move this over and then replace it with this. Okay, there you go. And then for this one, we'll use it later. So we'll see this. We'll take this, get, and then play with it later. So we'll have it set up right now. Okay, so that should be it. Let's compile and save this. And we auto test this to make sure that everything is working. And so let's go ahead and go into here and drop this into here, zero it out. And I think next up we need to set up a preview scene so that we can test this out. Okay, let's set up a very basic scene just to test out the body tracking. We'll put in a plane as a floor. I'll scale it up to like 20, maybe 10 is okay. Yeah. And then let's place in a directional light, which is movable. Let's just zero it out, and it's way too bright, so we'll just scale it down to 2. If I go in here, where are we at? Why does it look like it's way out here? Oh, tracking offset is also at 100, so we need to go back into here, just to 0 for the default value, and let's just compile and save. Okay, we're back there. And the sensor height depends on where you place this. So I'm placing it right now around like above my hips, so maybe 80 should be okay. And now we need a camera, so let's take a cinema camera. Let's just drop that, zero it out, and I think I placed it around 300 NZ, and then minus 2000. Okay, so that might be too far. Let me just see. Yeah, no, I think I'm gonna increase it to like 75 mil for the focal length. So it's way too high. So for now, let's just take this 180. I'm going to unpilot the camera because this is the tricky thing when you're using the sensor, and it's that you're not going to know which way is front and back. And I think usually it is going to be, let's see, I think it was 90 or minus 90 in Z. Okay. And so I need to open up TouchDesigner once again to test it. All right, so go ahead and open TouchDesigner on your side as well. Make sure your sensor is active. You can see me right there. And in Unreal Engine, what I'm going to do is that to make it easier for us to understand which way we need to be facing, which is the positive X, I'm just going to drop in a sphere like here, 0 the Y, and then give it an orange material. So that's where we need to be facing. And let's just zoom out. Make sure that when you're running this, your orange sphere for your hands are going to be on the right-hand side. So let's run it right now. Okay, I'm just going to stand right in front, and we should be able to see it. Okay, actually, I think I forgot something, and that's because I didn't add a reference to the OSC receiver here. So go ahead and do that. Let's save it, run it again. Okay, I'm going to exit this and then make sure we're down here. Okay, I'm going to stand in front, get my hands up, put it down. You can see it's reacting. But it's reacting rather slowly, and I'm guessing it's something to do with the workaround that we're using. But usually, if it's running okay, you shouldn't have this amount of latency. But anyways, now that we know that our direction is correct and we are receiving all the values, we can stop our TouchDesigner and then move on to the next component, which is going to be bridging the gap between our body tracking and the effects that we make in Unreal Engine.